Hello friends, this is Nikhil. So in this video we will see the full concept about directional overcurrent relays. What is it? Directional overcurrent relays. See, as the name says, it is basically a overcurrent relay. It is basically a overcurrent relay. What is an overcurrent relay? Overcurrent relay is such a relay which will operate if the current value as measured by the relay exceeds a specified value called as pickup current. What is the pickup current? Pickup current is the minimum value above which the relay will start operating, isn't it? If the current is more than pickup value, then the relay will operate. So that is basically the concept of an overcurrent relay. Now what is this directional overcurrent relay means? First, there is one logic called as directional logic. That means normally in case of a transmission line or in case of any protection circuit, the circuit which we are protecting, we are expecting that the current or the power to be flowing in only one certain direction. For example, let us take a power system. Power system means they will have a source as well as there will be a load. I always wanted my power to flow from source to load only, but I don't expect my power to come from the source to the load. Maybe because I am not interested or that causes some problem to me. So I am only interested or I wanted to make sure the current only flows in only one direction. If the current comes in other direction, I don't want that to happen. So then I have to use a relay which will sense if the current is coming in opposite direction and it will disconnect the line. In case of normal electronic circuits, we had one wonderful device called as a diode. What is this diode doing? Diode is having inherently directional property. That means it will allow the flow of current only if the current direction is from the P type to N type. If the current tries to come in this direction, it will stop it, or I can say it will break the circuit. So you cannot use a diode in case of a power transmission line, isn't it? So you have to use a directional relay. So directional relay not just operates only if the current value comes in reverse, but also if it exceeds a value called as pickup current. So there are two conditions to be satisfied. First is direction should be satisfied. That means the direction must be reverse. And next condition is overcurrent condition. It should be reverse as well as the current value should be greater than I pickup. Understood? So from this concept I can say this one relay will have two components. One is directional component and overcurrent component, or I can say directional element or overcurrent element. Overcurrent element is basically, as you know, generally we have studied in our theory, basically overcurrent relay will be having the construction is of which type of construction? Watt-hour meter type of construction, isn't it? Which looks similar to our energy meter. Watt-hour meter type construction relay will be used for overcurrent relaying purposes. But if you want to use directional overcurrent relay, you have to add another component to this overcurrent relay, which is a directional element. So basically directional element or directional property can be realized by using two type of relay construction. That is, they are basically induction type relays only. One is induction cup type, or the same watt-hour can also be used for directional relaying purposes or directional element purposes. One advantage of using induction cup is that you will get the time of operation, the ability to sense the abnormal condition or the direction will be quick in case of induction cup. As you already know, induction cup is having the least rotor inertia and hence induction cup operation is almost instantaneous, and instantaneous relays use induction cup type construction. These things we already know. So the next thing is, so directional element can be realized by using induction cup or watt-hour type, but generally overcurrent is based on watt-hour type structure only. These all are disk type induction relays. Let us say I am having an induction cup type relay. So basically the induction cup type relay construction will be like this, considering it is a 4-pole construction. If it is a 4-pole induction cup, this is the small cup, drag cup inside the 4 poles. So there are opposite poles is in this way. So two opposite poles will be given supply from the voltage. Let us say these two opposite poles are supplied from voltage and these two opposite poles are supplied with the current input. So basically for a directional relay, we require two inputs. One is current input as well as voltage input. This thing you have to keep in mind. Now always in a directional relay, the voltage input is called as polarizing input. So this may become an MCQ for various competitive exams. He will ask you in a directional relay which input is a polarizing input. So voltage input is a polarizing quantity or polarizing input. What is basically polarizing quantity? Polarizing quantity is having two purposes. One is this polarizing quantity only produces the main flux for the operation. Okay, for this entire relay to operate, the main flux is produced by the polarizing quantity, and it can also be called as a reference quantity. Why? Because the angle remains constant. The angle of the flux produced by this voltage coil always remains the constant and it does not vary. Okay, so this is regarding the voltage input. So the next input is current input, isn't it? Current input will be there. So current input is also producing some other flux. Okay, if the current direction is normal in a directional relay, the torque produced, the operating torque produced by the directional relay is a negative value. That means which kind of torque is this? If operation torque is negative, that means it is restraining torque. Restraining torque will make the relay to operate or no operation. So this will cause no operation condition. That means the relay does not operate. Suppose if the direction changes and reverses. Now the current direction is reverse. If the current direction is reverse, what happens? The operating torque will be greater than 0. That means it will operate. That means the relay will operate. Understood? So first, the entire relay to operate, first directional element should operate, and directional element will operate only if the current direction will reverse. So what is that thing making a overcurrent component to depend on directional component? If we generally look at the structure of construction of an overcurrent relay has got this kind of shunt magnet or M-type magnet, isn't it? Okay, and you will have a series magnet. The M-type magnet will receive voltage input and series type magnet will receive current input, and the disc is placed between these two magnets, isn't it? So when you are giving voltage input to the shunt magnet and current input to the series magnet, you are getting some flux and disc should rotate. But disc will rotate only when these both fluxes are displaced by certain angle, and that kind of displacement is achieved by placing a shading band, isn't it? A shading ring, a shading coil on the M-shaped magnet, isn't it? Only when you place M-shaped magnet, then this disc starts operating. So what we are going to use is, we are going to make utilization, or we will utilize this weakness of this directional element to make our purpose solved. What is our purpose? We want this overcurrent fellow to operate only if the directional fellow says okay. Understood? So what I will do is, I will take this shading band contacts outside, okay, a shading band contacts outside, and I will create a condition that this shading band contacts will be closed only if the directional property is satisfied. For example, let us say this is a normal open contact. It is a basically NO contact, normal open contact. Okay, shading band or shading coil contacts are normal open contacts. So I am having another unit called as directional unit. This is a directional unit. Okay, directional unit. So to the directional unit, I am giving voltage input as well as current input. Okay, so as long as voltage input and current input are given, as long as current direction is given normal, then the torque produced is negative. That means this contact does not operate. When the current direction becomes reverse, this contact will operate and it will closes the shading band. Once the shading band is closed over here, you are getting displacement between flux produced by shunt flux and series flux. And if this series flux value is high, that means if the current value is more, that depends upon your PSM, plug setting multiplier, isn't it? You will be having plug setting multiplier. Then the relay starts, or the disc starts rotating and the relay will operate. So this is the basic logic behind a directional overcurrent relay. So the torque produced by a directional overcurrent relay, the torque developed, the net torque developed in a directional overcurrent relay is generally given by this formula, which says voltage into current multiplied by cos theta minus tau minus k, where this k represents spring torque component, because there is a spring element which will be trying to restrain the operation of the coil or the disc. This corresponds to the spring. And V is the voltage, RMS voltage input, and I is the RMS current input, where theta is the angle between voltage and current. Angle between voltage and current, and this theta is called as maximum torque angle, MTA, and maximum torque angle depends upon the design of the relay. It's a design parameter. It depends on the design of the relay. So generally we assume that if the spring is negligible, the torque or the restraining torque of spring is negligible, I can write torque produced in a directional relay is approximately equal to Vi cos theta minus tau. Okay, several times some problems were asked in competitive exams regarding this particular formula. So what does this theta specifies? Theta is that angle between voltage and current when the torque produced will be maximum. Let us say if theta is what? Theta is the voltage between angle between voltage and current. If theta is equal to tau, it will become cos 0. What is cos 0? Equal to 1. That means the torque produced is minimum or maximum? Maximum. So tau is that angle that should be between voltage and current. If that condition is satisfied, then the maximum torque will be produced. Therefore, it is called as MTA, maximum torque angle.